In this video, I would like to explore digital currency and the blockchain used to record properties throughout the world as well as digital currencies. This is a real-time look at the blockchain exchange as cryptocurrencies are being traded. The current fiat system of monetary value is given to currency that has no gold or silver or any type of value except for faith in the system itself. So this is a decentralized system, a blockchain. Each time a sophisticated algorithm is solved the fastest, it's recorded in the blockchain on all the servers. All the different blockchain members get that digital recording of the block. The fastest one to the block to solve that problem will get awarded the block, and decentralized and recorded on each member's computer. So that would be impossible for the bad guy to try to infiltrate that, because in his attempts to solve the problem faster, he would have to take more time to do so. So it just simply won't be possible to do it faster than whoever intended to set forth the solution to that block. Blockchain.com is a Bitcoin block explorer service as well as a cryptocurrency wallet and cryptocurrency exchange supporting Bitcoin, Bitcoin Cash, Ethereum. They also provide Bitcoin data, charts, stats, and market information. Started in 2011. It's forecasted that it will generate an annual business value of more than $3 trillion by 2030. What is blockchain technology? Blockchain, sometimes referred to as distributed ledger technology, DLT, makes the history of any digital asset unalterable and transparent through the use of decentralized and cryptographic hashing. A simple analogy for understanding blockchain technology is a Google Doc. When we create a document and share it with a group of people, the document is distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to the document at the same time. No one is locked out waiting changes from another party, while all modifications to the doc are being recorded in real time, making changes completely transparent. Of course, blockchain is more complicated than a Google Doc, but the analogy is apt because it illustrates three critical ideas of the technology.
To everyone. So with this, as long as you are part of the network, you could access the entire history of transactions that have taken place since the blockchain was created, since inception. And the first block in any blockchain is called the Genesis block. So from the Genesis block to the current block, you will have the access to the entire chain. Any additions to blockchain have to be approved by the participant users in the blockchain network. So a majority of the members within the network have to approve of any additions to the blockchain. This is the public part of the ledger, and this is important because any additions made to the blockchain are permanent and are immutable. So immutable transactions are the transactions which cannot be altered. Once registered, they cannot be modified and are available for audit and verification 24/7. So this means that each and every detail is recorded, and any alterations can be detected by verifying it against everyone's personal version of the blockchain. So if someone's tried to modify a data on a block on a particular node, then the other ledgers which are having the same information will come to know that someone has modified data on a one particular node and they will try to rectify it. And the fourth property, no central authority is controlling the working of this blockchain network. It is a decentralized network. So this is where being decentralized helps. Everyone has a copy of the blockchain, which means there is no central point of failure. There is a single source of truth. Even if things go wrong, the data can be recovered. If one node goes wrong, the data can be recovered from other nodes. But what about security? How is privacy maintained if everything is so public? And here hashing encryptions comes into picture. It takes care of that. So now we will talk about the second feature, which is hashing encryption. But to understand hashing encryption, we need to understand the contents. What are the contents of a block? So a block in a blockchain is like a container that holds aggregated transactions. It contains certain set of transactions. So we will see what all things construct a particular block. So a block has two parts. It has a header and it has the second part is the transaction details. It is the set of transactions which are aggregated in this block. Now the header has following set of attributes. It has the block version number. It has the hash of the previous block to which it is linked, the current timestamp, the timestamp at which the block was verified, the nonce, we will see what is the attribute, what is the meaning of nonce, and the target value. Now, the transaction details are nothing but the example which we talked about earlier. It is the transaction which the sender and receiver are sharing. The sender is trying to send certain amount of Bitcoin from his account to the receiver's account. Now, it is represented in the form of a 256-bit hash value in the header called as Merkle root or the hash root. So basically, the Merkle root is the hash of all the transactions structured in a Merkle tree called binary tree. It's a kind of a binary tree, and the hash value of the root node of the Merkle tree is called the Merkle root hash. So the transaction details of a block are contained in the header in a hex value known as Merkle root. The Merkle root can be calculated in this way. So basically, the list of transaction, each transaction is passed through a hashing algorithm. Then all the hashes of the transactions are paired and then again passed through another hashing algorithm until only one value remains, and which will be the root. Now let me tell you how a hash function works. Blockchain utilizes a hash function to perform cryptography. Data from a data set of random size is sent as input to a hashing function to get an encrypted value of fixed size. And that is the feature of any hashing function. So some unique properties of hashing function are these are deterministic. The same input will always produce the same hash output. Small changes in the data can drastically change the output. Basically, any small change to the input produces an output that's drastically different from its previous obtained outputs. It can be computed easily. The output values can be obtained without a whole lot of calculation, and hashing functions are one-way functions. Basically, you won't be able to determine the input based on the output value. So you can't do the reverse calculation. Now let's go back to our block we were talking about earlier. So as we were discussing, what are the features in the header? The previous hash is the resultant hash of the previous block in the blockchain. And this is the way two blocks are linked together. Now, transaction details, these are used to provide details about the sender, receiver, and how much money they want to exchange between them. And this is a list of transactions, and they are structured in a Merkle tree, and the hash of the Merkle root is put in the header. Nonce is a value that is varied to create a unique hash address of the block, which should be less than the target hash value. So this is the structure of the header. It has a block version number, basically the sequence number of the block. It has the hash of the previous block, the timestamp when the block was mined and verified, the nonce value. The header is then, this entire header is then passed through a hashing algorithm. In the case of a Bitcoin network, it is SHA-256, and a hash value is generated. And now this hash value becomes the hash value of the block. Now this value is a 256-bit value that is used to uniquely identify the particular block. So SHA-256 ensures that alterations to data can be easily detected. So for example, consider these two blocks in the blockchain. They have a similar structure and definitely different hash values. Now, if someone alters the transaction details in the first block, the corresponding hash value of the block would change too. Now the values of hash value of the first block and the previous hash value of the other block will not match. Basically, the block subsequent to the hacked block will get delinked. Now this will raise an alarm among the users, informing them that data alteration has taken place. The users will then be able to flag the block, so the alteration can be easily identified and rectified immediately.
The world now utilizes the blockchain system to record property deeds as well as cryptocurrency. The current fiat system of centralized banking is now on its way out, and those with eyes to see can see the future is indeed in cryptocurrency and the blockchain method of decentralized recordation of property, and the future of the monetary system is now indeed cryptocurrency, and the current cash-based fiat system is going away.